Hi guys, welcome back for the 100 days challenge of NEET as well as JEE Mains Physics. So very good evening guys. So many of you are having doubt why you have displayed this slide. Yeah, I'll explain you why. See, hi guys, hello. So in our NEET World, no, one of the program is going on. Our program is for the NEET 2026, which is starts from July 1st, right? So for that, the admission for the 11th, 12th as well as the repeaters, okay, these are the students can apply for the programs. Like who have passed the 10th, they can apply for the 11th, and who have completed the 11th, they can apply for the 12th, as well as so if you want to repeat the NEET program for the upcoming 2026, right, you can join the Power Step to Medicine. Okay, so we are giving with the affordable price of 3333 per month. Okay, this is the price tag of the courses. So let's go into the topic. Yes. Yeah guys, so today's topic which we are going to see is torque and moment of inertia. In last topic we have completed power and the efficiency, right? So today we will start with the torque as well as the moment of inertia, and we will see what is torque and what is moment of inertia and how the questions will be asked in JEE mains as well as NEET examination. Like we will start from the basic questions, okay, and I'll give you some questions as a homework. You can try that and give the answer in the comment boxes, and we'll verify that, right? So first thing, so what is torque? See, torque is the turning effect of a force applied at the distance from the axis of rotation. So when you are considering about the force now, like we can take in a one dimensional or a two dimensional, whatever it is, right? But for one dimensional we'll say it is a force, for two dimensional we'll consider it as a torque, right? Turning effect, no, turning effect we'll say. So from the distance from the axis of rotation we'll say, okay, so which is denoted by the letter tau. We'll say it a tau, simply like this, okay. In T will be there, no, the down part I should bend it, that is tau. So formula is R cross F, okay. So where I can write it as R FR sin theta also. So either R cross S and FR sin theta, where I can say the SI unit is Newton and meter, okay. And one more thing, the maximum when the angle is theta, torque is maximum. When angle is 0 or 180, torque is minimum, okay. I know sin 90 is 1, sin 0 or 180 is 0, right? This is about a torque. Moment of inertia. So moment of inertia is nothing but resistance to change the rotational motion. So which changes, like resistance to change the rotational motion is nothing but the moment of inertia. So for that formula is here given. So this is the formula. In the x axis they have given, I can say mr square, moment of inertia equals to mr square, okay, mr square. So in discrete form now, I is equals to integrate r square dm. I'll write it here to dm. In discrete form guys, like I am calculating, suppose some object is like this with uneven. So I am calculating what is the moment of inertia at this point, point number 1, moment of inertia at point number 2, moment of inertia at point number 3. So every point I need to calculate. So moment of inertia is equal to integral r square dot dm. This is the formula for the discrete form. Okay. Can we go for the next thing? Yeah, it depends on mass, yeah, shape and distribution, axis of rotation. So from which axis I am considering to find the moment of inertia. See, suppose if I consider this is the pen, okay, or a cylinder I will consider. If I consider this is the point to center point, moment of inertia will be changes when I compare to the edge or this point, okay, or either this point. So that's what they are saying, axis of rotation, okay, depends on axis of rotation, mass, shape and distribution. So there are some standard formula for the moment of inertia which you need to remember. The first one is thin rod. So axis of rotation, like the axis is given from the center. So thin rod in the sense, like if I consider this is the rod, no, if I want to find what is the moment of inertia about this axis, no, that's the formula is ml square by ml square by 12, where L is the length of the rod and m is the mass of the rod, okay. And thin rod at the end in the sense this is the end, either this one or this one. So moment of inertia is ml square by 3, okay. So what we have seen, it is depends upon the axis also. So now we can say, no, like from the center it is ml square by 12, where from the edges, no, it is like end, it is ml square by 3, okay. So similarly for every object the moment of inertia has been given here. So for the ring, for the center is mr square. For the ring of a diameter, it is mr square by 2, excuse me guys, sorry, yeah, a solid disc of the center of mr square and solid disc of the diameter mr square by 4, solid sphere it is 2 by 5 mr square, hollow sphere is 2 by 3 mr square and solid cylinder is mr square by 2 and hollow cylinder is mr square. You can take note of this. We can go for the next slide. Yes. So here are the some other formula: solid sphere, hollow sphere, solid cylinder and hollow cylinder. So mr square by 2 mr square by 5, 2 mr square by 3 of mr square and mr square. These are the formulas for the moment of inertia, okay, for given certain objects. You need to remember guys, these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are the formulas you should remember, okay. Next, torque and angular acceleration. So what is the relation between torque and the angular acceleration and how the moment of inertia comes in this place? Yes, see, torque is equals to moment of inertia into alpha, where alpha is the angular acceleration. So I is the moment of inertia. So A is angular acceleration for rotational equivalent of F is equals to ma, okay. Excuse me, I'm getting dry cough, sorry guys. Yes, so rotational kinetic energy. So formula is like for the kinetic energy formula we know, no, K is equals to of mv square, right. So instead of mass we are using I instead of v, omega. So this is the angular or rotational we'll say, okay, this omega square, right, angular velocity, moment of inertia I. We'll see next one. So theorem of moment of inertia. So two theorems are there: parallel axis theorem, perpendicular axis theorem, which is most useful for solving the problems, okay. So moment of inertia for parallel axis theorem, I is equals to I center of mass of the given object plus md square, okay, md square from the distance from where you are considering. suppose an object is given like this, okay, I want to find the moment of inertia of this axis, okay, from this point. Excuse me. Yes, from this point I know some moment of inertia, that is moment of inertia of center of mass. So this is the distance, no, that distance is said to be d, okay. So the mass of the given object. So you can use this parallel axis theorem to find this axis. Similarly, perpendicular axis theorem is there. For that, I moment of inertia of z axis equals to moment of inertia of x plus moment of inertia of y axis. It's planar bodies only, for the planar bodies only. Keep remember, only for the planar bodies it is perpendicular axis theorem will use. Yes. So whatever I said for JEE and as well as NEET also, this is the thing. So apply energy and conservation principle when needed, like tau is equals to I alpha for the rotational motion, okay, or like F is equals to ma, we use no, F is equals to ma. So instead of F, tau, instead of m, I, instead of a, it is alpha, okay, for the rotational kind of thing. Always check the rotational axis and memorize the standard formula of the moment of inertia. These are the things you should remember. So okay, first question, find the torque about the origin when a force of F is equals to 3 Newton act on the particle when position vector is r is equals to 2k, right. I know the formula, no, tau is equals to r cross F, where r is nothing but 2k cap cross F is 3j cap, okay. One thing I need to remember, I, j, k. So I cross j will give k, j cross k will give I, k cross I will be given j. This is in this way. So if I take in opposite way, I should add the negative symbol, no. So k cross j, from going k to j, no, it will give I. So which is nothing but 2, 3, 6, it is I minus, this is the answer, this is the torque, okay. Can we go for the next question? Yes. Okay. Moment of inertia of the force F is equals to 4i cap plus 5j cap minus 6k cap at 2, 3, minus 3 about the point 2, minus 2, minus 2 is given, okay. So point is given, it is the initial point and there is the final point, no. So R initial, R final. I know the formula, tau is equals to R cross F, R cross F, where F is given, R I need to find, R is nothing but R final minus R initial, where 2i cap minus 2j cap minus 2k cap of minus 2i cap plus 0j cap minus 3k cap, which is nothing but 2 minus 2, 0i cap minus 2 minus or plus 0 minus 2j cap minus 2 plus 3 minus k cap. This is the thing, no. So I can use that 0 I cap minus 2 j cap minus k cap cross 4 I cap plus 5 j cap minus 6 k cap. So how can I do this one? Like for the one simple thing, j cross k or k cross j has been done easily, but if these things given, no, take a determine I, j, k. What is the number given here? First thing 0 minus 2 minus k, 4, 5 minus 6. When you want to find I, know, first thing write it here, I plus minus plus, here plus minus plus, j plus k. excuse me, sorry guys. Yeah, so when you are finding for I, close this one and cross multiply. So minus 2 minus 6, it is 12, minus, minus 5, no, minus of minus 5, so plus 5. Okay, now if you want to find J, no, close this and cross multiply. So 0 minus 6, 0, 4 minus 1 minus 4, minus of minus plus 4. So similarly for k cap also, close this one and cross multiply these two. Okay, cross multiply these two, you will get I, J, K in terms of torque. Okay, for the torque you will get the values. This is the easy way to find it. No man, I am Indian man. Bhaiya, are you Bengali? I am Indian, I am Indian. Okay, we will go for the next thing. Okay, so here a force is given. I will zoom it little bit. Yes, a force is given, that is F is equals to alpha I plus 3j plus 6k, R is equals to 2I minus 6j minus 12k. The value of alpha for which angular momentum about origin is conserved. So origin is conserved in the sense, what I can say, tau is equals to R cross F, where tau is nothing but 0. I need to find the value of R cross F. I will write here. First thing, I need to draw, determine a modulus alpha, I, J, K, right. So next one is R, no, 2 minus 6 minus 12, and F is alpha 3 6. So if I want to find I, no, I need to close this thing, right, close the terms. For I, write down plus minus again plus for the k cap. So minus 6, it is minus 36, again minus I need to keep. So 3 12s are 24, 36, no, minus of minus, no, 36. Now for the I cap, now I need to close this, so cross multiply. So this is 12 minus, so minus 12 alpha, so it will be plus 12 alpha, 12 alpha. Now next one, yes, for k I need to close. Next one will be, it is 6, 2 3s are 6, again this one will be minus of minus plus 6 alpha. This is the thing, guys, that's it. Okay, now I can easily find, no, I can equate to 0, I can get the answer for the alpha. Yes, we'll see what's the next question. Yes, I'll give you the question, guys. Okay, so 3 particles each of mass m gram are situated at the vertices of the equilateral triangle ABC. Then the moment of inertia of the system about a line x AX perpendicular to AB in a plane is, okay, let me draw the triangle first. This is the triangle, right, which is of mass kept at the vertices of the triangle. This is A, point A, this is point B, and this is point C, right. So let me consider this is AX line, okay, AX line which is perpendicular to AB, right. I need to find the moment of inertia first thing. What is the length here? L. And what is the length this one? L by 2, and this one at this point it's 0. For this point from the axis 0, from this axis to this point it is L, from the axis to this point it is L by 2. First thing, moment of inertia is equals to moment of inertia from, I will consider 0 like O, point of axis to the point A plus IOB plus IOC, right. So now I can find easily, yes or no? So for this one it is 0, consider its origin, exactly the origin only, no need to worry about that. So next one is ml square for B plus, for this one L by 2 the whole square, so which is nothing but ml square plus ml square by 4, which is equals to 5 ml square by 4. This is the answer. I will give one more question here. Let us try that question. And before that I will show you the formula also for that, okay. Yes. So I will give a question based on the solid disk only here now. So what is the moment of inertia? Of mr square. Keep in mind of mr square for the solid sphere. Now we will do the question here. Suppose disk is given, disk is there which is having mass m and radius r. So from this disk now I have taken some part of disk again which is having mass m by 2, let me consider m by 2, and radius r by 3. This is the thing I have removed, okay, this is the thing I have removed. I need to find what is the remaining moment of inertia. Initially moment of inertia will be I is equals to mr square by 2, right, mr square by 2. Now I have removed certain point and I need to find what is the remaining moment of inertia there. So this is the thing. So moment of inertia final should be equals to moment of inertia of initial minus moment of inertia of the removed part, okay, moment of inertia of the removed part. So what is moment of inertia of the initial thing? mr square by 2, where for the second thing remaining part no minus m by 2 into r by 3 the whole square by 2, that's it, okay. Only the thing we should add is the remaining part I need to subtract it, m by 2 into r by 3 the whole square by 2. So what I will get here? mr square by 2 minus this is m and r square by 2 into 2 into 9, that's it guys. So only calculation part is remaining. So I final will be equals to mr square minus mr square, this is 2 times 9 2s are 18, 18 2s are 36, divide by 36, no, yeah. Now we can find easily. So 34 mr square by 72. So this is 17, this is again 36. So which is nothing but 17 mr square by 36 is the final answer. So whenever a question can be asked like this, no, simply you can subtract it from the given moment of inertia, okay, and then I can find easily, right. I will give one more question here. See, from the center we have considered, okay. Suppose let me take a hollow sphere. Hollow sphere is there, okay, which is in between nothing is there, no. So what is the moment of inertia there? 2r by, I mean mr square by 3, 2 mr square by 3. Now if I consider some part has been removed again, for example 2m and again r by 2 the whole square, I mean r by 2 has been removed. Now what I can do? Same thing. So initially there will be some moment of inertia, that is 2 mr square by 3. Again I need to subtract it, minus I need to 2m into r by 2 the whole square by 3. That's it, guys. Okay guys, so we'll continue with the next session. Until then, bye bye guys. You can enjoy your Sunday holiday. Bye bye. Who is this? Clip and Grip. Hello. We'll end the session here. Okay. Until then, bye. We'll meet on Monday.